So here it has been asked, consider the experiment of throwing a die if a multiple of 3 comes up. So multiple of 3 means multiple of 3. So that will be 3 and 6 only. Since why in die 6 is the highest value which can be obtained. So if a multiple of 3 comes up, throw the die again, and if any other number comes up, then we have to toss a coin. Find the conditional probability of the event the coin shows a tail, given that at least one die shows a 3. So here also we have to find the conditional probability, that is, we have to find the probability of the event, that is the coin shows tail, the coin shows a tail, given that at least one die shows 3. At least one die shows 3. So, so here suppose we assume that let there be n number of throws. Let there be n number of throws where a multiple of 3, where a multiple of 3 occurs every time. Occurs every time. So therefore, the probability of getting a multiple of 3, probability of getting a multiple of 3 in a single throw of a die. So that would be 2 by 6. So that would be 1 by 3. Since why in 2 outcomes we are getting a multiple of 3 and there are 6 possible outcomes. So it will be 1 by 3. And so therefore the probability of getting multiple of 3, getting a multiple of 3 in all the n throws, in all the n number of throws. So that would be 1 by 3 into 1 by 3. So that would be n times. So that would be 1 by 3 whole raised to n. This should be n times. So it is 1 by 3 whole raised to n. So now we have to find the probability of getting a 6, of getting a 6 in one throw, in one single throw of a die, in one single throw of a die. So that would be obviously 1 by 6. And so the probability of getting a 6 in all the n number of throws, in all the n number of throws, so that will be equal to 1 by 6 whole raised to n. So therefore, the probability of getting at least one, getting at least one um, okay, but there is something wrong here. The probability of getting a 3 in at least one throw, in at least one throw, getting a 3 in at least one throw. So that would be 1 by 3 whole power n minus 1 by 6 whole power n. So we have found the probability of getting a 3 in at least one throw out of the n throws, out of the n number of throws. Okay, so then suppose in the n plus 1th throw, Means in the next row, suppose we will get something, some number which is other than 3 or 6. So therefore the probability of getting a number other than a multiple of 3, other than a multiple of 3, so that would be so except 3 and 6 there are 4 numbers, so that would be 4 by 6, so that would be 2 by 3. So this is the probability of getting say 1 2 4 5 in the n plus 1th row, in the n plus 1th row. So in the n plus 2th row, we have to throw a coin. We have to toss a coin actually. So therefore, the pro probability of tail, getting a tail in the coin in the n plus 2th row, in the n plus 2th row. So that will be obviously 1 by 2. So now, therefore, the required probability, the required probability of getting at least 1 3 in the die, at least 1 3 in the die, and a tail, the coin, and the tail in the coin at the end of the tail in the coin at the end of n plus 2th row. So that would be equal to 1 by 3 whole power n minus 1 by 6 whole power n times the probability of getting a number which is not a multiple of 3 in the n plus 1th row, so that would be 2 by 3, and times the probability of getting a tail in the coin, so that would be 1 by 2. So in this way, we can find, therefore, the probability of getting at least 3, the probability of getting at least a 3 till a tail is obtained, the probability of getting at least a 3 till a tail is obtained is will be equal to summation of n goes from 1 to infinity 1 by 3 whole power n minus 1 by 6 whole power n into 2 by 3 into half. So why we are adding it from 1 to infinity? Since this here we are saying that we are considering n number of throws. So this n can be anything from 1 to infinity. So we have to add them. So then we will get what? So this will be uh so this will be 1 by 3 obviously. So this 1 by 3 will come outside since it is a constant. So then I can write summation 1 by 3 whole power n, where n goes from 1 to infinity, plus we can write summation n goes from 1 to infinity 1 by no, sorry, this will be minus 1 by 6 whole power n. So 1 by 3. So this will be an infinite GP, and this will be also an infinite GP, infinite GP. So for infinite GP, as we know that suppose we have to find the summation of uh, a r power suppose n minus 1, where n goes from 1 to infinity. So then that is the sum of infinite GP, and that is given as a by 1 minus r. Okay. So then here also this we can apply. So this will be a by 1 minus r, then minus 1 by 6 by a by 1 minus r. So therefore this will be 1 by 3 into 1 by 3 by 2 by 3, then minus this is 1 by 6 by this is 5 by 6. Okay. So this will be 3, 3 will cancel, 6 and 6 will cancel. So this is 1 by 3, 1 by 2 minus 1 by 5. So this will be 1 by 3 into this is 2 5 is 10, 5 minus 2. So this will be 3, 3 will cancel. So this will be 1 by 10. So this is the final answer. Thank you.